Hello friends, this video on P block part 59 is brought to you by examfear.com. No more fear from exam. Talk about my popular compounds of xenon. For xenon, we have xenon and fluorine compounds and xenon and oxygen compounds. These are not reactives, we don't have any compounds. Krypton also is very limited reactive, so we don't have much. But for xenon, we have some. For my radon, it is radioactive, so we don't have much compound here also. But for xenon, we have few. So let's start with xenon and fluorine compounds. Actually, xenon and fluorine, it forms 3 binary fluorides. In fact, xenon forms 3 binary fluorides. Fluorides of xenon is there actually. That is XEF2, XEF4, XEF6. There are 3. Yeah. Okay. And it actually depends on the amount of fluorine present and the temperature. We'll see that actually. So if you take the xenon and react with fluorine at temperature of 623 K and with the 1 bar pressure, what you get is XEF2, and that is a solid. In fact, xenon is a gas, fluorine is also a gas. You take the same thing, but in this case you have the ratio of 1 by 5 and you increase the temperature to 873 Kelvin and the pressure to almost 7 bar. So in that case what you get is XEF4, and that is also solid. You take the same xenon and fluorine gas, but in this case you increase the temperature ratio of xenon and fluorine to 1:20, more and more fluorine, and temperature to almost 573 Kelvin, and but increase the pressure to 60 to 70 bar. So what you get is XeF6, and this is also solid. And all these reactions, all these 3 reactions I told, they take place in the sealed nickel vessel. Okay, so we have 3 different xenon and fluorine compounds. Let's study all these things in detail. The first one is XEF2. XEF2 is xenon difluoride. Xenon difluoride. So again, the one method as I just told was to prepare this xenon difluoride. Right? Take xenon, take fluorine gas, and xenon will be in excess here, and a temperature of 673 K, 1 bar pressure, you get XEF2, and this is solid. In fact, this is solid. Okay, the other way to prepare my xenon difluoride is you can directly heat xenon with excess oxygen difluoride. So you have O2F2 and you heat this xenon, both are gas, and you get XEF2. My solid and my oxygen will go out. This xenon difluoride is actually white, crystalline, solid, and it melts at 413 Kelvin. Okay, this xenon difluoride actually dissolves in liquid hydrogen fluoride. So this dissolves in my liquid hydrogen fluoride. Okay, but still the solution is non-conducting. Okay, it dissolves in water also. Xenon dissolves in water, but the reaction is pretty slow. Okay, with the Lewis acid, for example PF5, it forms adduct. For example XEF2, you have some Lewis acid, it will form an adduct. XEF plus charge, PF6 minus charge. Okay, this xenon difluoride will also react with hydrogen. It will form hydrogen fluoride and xenon is back. If we talk about the structure of XEF2, this is my xenon with 1, 2, 3, 4, 5, 6, 7, 8 electron. 1 fluorine is here. Let's suppose 1 fluorine is here. So I have 1 lone pair here, 1 lone pair here, Okay, one lone pair here. So I have 3 lone pair plus 2 bond pair. That is my sp3 dehybridization. 3 lone pair and 2 bond pair as per Vesper theory is my linear structure. So this is the linear structure and this angle is 180 degree. And the bond length, xenon and fluorine, the bond length is 200 picometer. So that is my structure. Please remember this structure for XEF2 xenon difluoride. It is linear and sp3 dehybridization. Let's talk about the next compound, that is xenon tetrafluoride. Xenon tetrafluoride. XEF4. This is also solid. One method we just discussed, you take xenon and fluorine in the ratio 1:5 and you to heat it at a high temperature and some 7 bar pressure, you get xenon XEF4. That is one way. Right? Let me write the equation. We just discussed that. At almost 873 K and 7 bar pressure, you get XEF4, and this is my solid. And this will happen in a sealed nickel container. It can also be produced by mixing my xenon and fluorine in instead of using my sealed nickel container. Instead of using my sealed nickel container, I can also use my quartz vessel. And in this case I have to provide sunlight. Okay, talk about the property. Again, this is colorless crystalline solid. This is my colorless crystalline solid. It sublimes easily. It's a good fluorinating agent. Actually, it can fluorinate unsaturated hydrocarbon. We have seen fluorinating agent, that means it will add fluorine to that particular compound. So it's a good fluorinating agent. It can fluorinate even non-unsaturated hydrocarbon. It doesn't form any adduct with Lewis acid. So if you take XEF4 with my, it suppose PCl5, it will not form any adduct. Okay, it reacts with water. So if we have XEF4, it will actually react with water at a little higher speed as compared to my XEF2, that is xenon difluoride. So it will give you xenon trioxide, my fluoride and oxygen. Okay, but this guy, it will form adduct with SBF5. So it will form xenon XEF3 plus and SBF5. So SBF6. This reacts with hydrogen also. XEF4, it will react with hydrogen. It will form again HF and xenon is back. Okay, let's talk about the structure of this. So XEF4, I have my xenon 1, 2, 3, 4, 5, 6, 7, 8 already there, and I have to put 4 fluorine, right? 1, 2, 3, 4 fluorine I have put. So I have 2 lone pair here, 1 lone pair here and 1 lone pair here. So I have 2 lone pair plus 4 bond pair, and hybridization is sp1, p2, p3, d1, d2. sp3 d2 hybridization. So as per Vesper theory, it is square planar. Please remember the shape of this square planar for XEF4. The next one was XEF6. So we have told how to prepare this using my xenon and fluorine. You have my xenon, I have my fluorine, where in this ratio of 1:20, I think. So you have almost 573 Kelvin temperature, the high pressure of 60 to 70 bar. You get XeF6, that is my xenon hexafluoride. Okay, and this is also solid. You can also prepare this by reacting my xenon tetrafluoride, it is XeF4, with some fluorinating agent like O2F2. For example, I have XeF4 and I have some fluorinating agent. It will add fluorine to this. You get XeF6 plus oxygen. So both are fluorinating agent actually, but O2F2 is dioxygen difluoride, is a stronger fluorinating agent. This will add fluorine to xenon tetrafluoride. It will become xenon hexafluoride. Okay, it is pale yellow solid. Pale yellow solid, and it reacts violently with water. So if you have XeF6, you have water molecules, a violent reaction, it forms xenon trioxide and my hydrofluoride acid. Okay, if you do a hydrolysis of xenon hexafluoride, you get two products, and this is an important reaction. Just understand this. You do a hydrolysis of this xenon hexafluoride, you get XeOF4 back to HF, and if you do hydrolysis with more water, you get XeO2F2 plus 4HF. This is a very important reaction actually. So on hydrolysis, you get XeOF4 and XeO2F2, and this is again on the incomplete hydrolysis. Okay, this is the critical reaction. Please remember this. This is called xenon oxyfluoride. This is xenon oxyfluoride, and this is xenon dioxyfluoride. Xenon oxyfluoride. This is my xenon dioxyfluoride. Okay, and it forms adduct with Lewis acid. So XeF6 BF3 kind of thing it will form. It forms adduct. Okay, like other xenon fluoride compound, it reacts with hydrogen. So we have XeF6, you react with hydrogen, it will form same compound, that is HF, and xenon is back. Actually, it reacts with alkali metal fluoride. For example, I have XeF6, I have alkali metal fluoride, you get MXeF7. And this M can be my sodium, potassium, like that. Okay, and this is actually thermally unstable. This is thermally unstable. Actually, you take two of these, and then again they react to form M2XeF8 and XeF6 back. Okay, this is little thermally unstable. Talk about the structure of this. Let's see. XeF6, I have a xenon 1 2 3 4 5 6 7 8, right? So I have to add 6. So 1 2 3 4 5 6, I'll add fluorine. So I'm left with only one lone pair. So I have one lone pair plus 7 or 6 bond pair actually. One lone pair, 6 bond pair. That is, this is sp3d3 hybridization, right? 1 plus 3 plus 3. Yeah, sp3d3 hybridization, and the shape will be octahedral. Okay.
Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.